Hi YouTube. This is the last installment of the K3NG rotator project. As you can see, I've just yet to solder this paddle down. It's a bit wobbly, so yeah, it's not soldered down, they're just resting on the contacts, but these buttons will eventually light up and they'll be working. So I haven't soldered everything down, up, down, left, right, etc. These will all light up on movement, along with this over here. As you can see, we're facing just a little off of 360 degrees and elevation at 90. My parking position 330 and 90, so it's just off of. I'm going to move it up a little bit more, and I'm just going to move it around so that we get past 360 degrees and we're going to go into overlap, which is there. So we just look at that now. Gone past 360 now. Overlap LED is blinking. GPS locked. Nothing connected on the way of serial, but we are basically all working well. Now I'm going to try my hardest with one hand to invoke the parking function. It's rather tricky as the actual controller under there, its relays and so on and so forth. But I'm going to try my hardest without blowing it up to invoke the parking function, which is the handy pliers that go in there somewhere. It's just done. There we are, parking. That's one part done, and there we are, 330. And I think it's gone a little bit way past that, so it's probably not the best video to do. Everything blinking and going potty at the moment. So hang on a second, let's go down a bit. I'm saying we've gone the wrong way a bit. Down, down, down. Yeah, so let's try parking again. Over the button. It's not working, so I'm going to have to do that again. Let's try it again. There we are. Ah, yes, now we're parked. So there we have it. I'm tracking, parked, parking, GPS lock, serial data, blink, and rotation whenever we're rotating. So let's try moon tracking, for example. Let's get rid of this, switch on moon tracking. Unfortunately, the switch is around the wrong way. I need to change that. So let's invoke moon tracking until I switch this switch around. This is reversed. There we are, moon tracking. Rotation comes on and it gives us an idea of where we're going. And if you're wondering about this, I'm not intending on selling these. These were literally the price of one was for the price of 10, so I said just give me 10, and I've changed the design. If you look at that design, it's slightly different. It hasn't got the moon tracking, sun tracking and all the rest of it, buttons and the preset, so that was a mistake, and so on and so forth. So there we are. So where are we? We're still moving. And that's it. We're just a few degrees off. We're not too fussed about 1 or 2 degrees of the beam width of the antenna. We'll bring that into line. I can easily sort of like adjust that if I really want to be anal, but it's not necessary. Yeah, look, a couple of little presses of the buttons, we're nearly there. I had to add some caps here for stability purposes. They're not brilliant, but they do filter out a lot of the noise. You can see a lot of wiggle of the cap that wasn't making brilliant contact, and that's it's just a little bit of noise. Not the most fluid of power supplies, but there we are. Well, it's actually coming for this thing here. It's button 12. So there we are. K3NG rotator project. I'll quickly come back from here. Invoke parking again. Oops. You can see the lights. Oops, under there. Relays engaged. Oops. Yeah, it's like being on a merry-go-round video for me, isn't it? When it gets to 330 and 90, that's when it'll be fundamentally parked. I feel sick. yeah, with my video. Should come away feeling a bit groggy. Yeah, well, that's the elevation part done. When it reaches the azimuth part done, the parking light will change. This light will change to parked. With a bit of luck. There we are. Oh, good. Thanks for watching. And obviously there's the very quick cabling. Goes out to our 7-pin lead. It goes to our AC controller. 330 and 90, depending what angle you're looking at. And there's the obligatory 847 underneath. An obligatory microphone. And there's that's one of the early attempts at the project, which I sort of abandoned. I wasn't very happy with the surrounds and everything. It looks a bit cack. This display's black actually. This is really nice. And I had a bit of problem with bleed through from the LED, so you know the whole lot of this lit up, so I had to put some sort of sleeving on there. This one does actually work, though. It's all fully wired. But let's get rid of that a minute. Yeah, it works pretty well. It's a shame it's been neglected. This is the I2C expander. Various resistors for different values of LEDs. I wanted to get the colour spot on. This is the main connector that goes to this board here, which that connector tallies up with that connector. These connectors, all your A pins for your analog inputs, which go to all of those pins there, upside down unfortunately, sorry about that. Hang on, there we are. The analog pins there. Clock, data, VCC ground. What's that there? Oh yeah, presets and moon tracking, 5V DC. So that's for the preset. Start for preset. Now, oops, so we can get that to focus. Sun tracking, power button, ground, parking enable, and moon tracking. And all these other buttons do basically up, down, left, right, whatever you, which are all necessary. These are the addressing for this chip. So whatever, if you jump these out, at the moment I believe this is on 0x27, but if you jump these out, you can change the addressing. It depends if this is a PCF 8574A, and this one's an 8574P. So this is the earlier version. If it's got an A next to it, it means it's a higher addressing. It's wired internally. There's another 4 address lines wired internally, and most of these come standard on 0x3F. So yeah, just be wary of that. Depending on, I put 2 lots of moon tracking and parking and stuff like that. So I wasn't quite sure where this is going to move out from. This is a auxiliary 5V. If you want to take your 5V off of something else, and buzzer and so on, it's just a look at this underneath. Basically, I've got 2 controllers. I've actually got 4 controllers, but so I eventually wanted to build 4 of these for each controller. So there we are. But yeah, so 1, 2, 3, 4. And this is at the heart of the guts. This is a WeMOS Mega 2560 with Wi-Fi. So this is got built-in Wi-Fi, which is quite good. And you've got your addressing. Depends whether you're using MCU, whether you're using the ESP, and so on and so forth. If you say you go MCU to ESP, whether you can go USB to MCU, USB to ESP. And standard GPIOs and stuff like that, I think it is, if I remember rightly. But there's the little Wi-Fi symbol, so that's for Wi-Fi. They're pretty good, but that's at the heart of both of these. Some of my patented shield. I think this may have been damaged somehow. I think the analog's gone. Don't know how I've managed to do that. I reckon it could have shorted out on something here. I think so. But there we are. Yeah, all good stuff. Work in motion, or should I say work in progress. You can look under there. Look, there's the actual WeMOS. There's the screw terminal shield. Yeah, that's my design that as well. So this is, I've got, obviously everything is my own design, not ripped off from anyone. It's totally individual. And there is my. I was knocking. Well, I made these up about 5 years ago. I was knocking these boards up. These screw terminal shields before some other weasel on the internet decided duplicating them. They're these screw terminal shields. I think everyone, their third uncle's made an iteration of this one. I think everyone's copied that, cloned that, copied that. Which is a bit of a shame. Oh, naturally you've got your GPS antenna here as well. That's hard. Can't remove that. And there's your SEO, SDA, etc. Yeah, maybe one day I'll get around to tidying up. So there we are. Right, nothing else really to show, to be honest with you. I think that's video over. Not the most professional thing, and I really don't care, to be honest with you. So because it's just really, this is more for me at this specific stage. But yeah, so there we go. I even built a, if it's here, because I think it's under this power supply that we plonk there for testing purposes, a cable tester. Just while we're at it, oops, this is another project that's half, oops, it's my APRS project. So hang on a second, let's get this round the right way. It's my APRS project. Get something underneath that. This is an Arduino, naturally a Nano, Bluetooth, that's a HC06, GPS, standard PIC chip. I think it's a 16F84. Yeah, basically this goes to the radio, this goes to the GPS for position information, just a Neo 7 U-blocks type thing. Basically information from here comes to the radio, from the speaker comes in here, gets routed through here into this, which then decodes the Bluetooth packet information. Decodes the information, sorry, decodes the APRS packet information, and then sends it to Bluetooth, and then Bluetooth onto an Android phone with APRS Droid. And then you can use APRS Droid on Android to look at other people's packets. So not only are you sending from here, you're actually receiving through here, and the said LEDs light up accordingly. So we are, APRS power, connect, well, CD, carrier detect, GPS, and then transmit. And then on over here, basically it's two boards that are similar to the Tiny Track 3, I think it is. There's about 1 million clones out there for the Tiny Track 3. And then this actually would do the same as that. That's a thingy version, but with that. But I thought, you know, at the end of the day, it was meant to be. This is the original, which is looking a bit messy now, which used to be in the car. So that's a slimmed down version of that. So there's the Tiny Track. There's the Bluetooth decoder, and because it's been in the car, that's a bunch of relays that I can switch stuff on and off of. It's just a relay board. These are my GPS input. It's a prototyping board, but basically all of that, this is just a buck converter, and all of that there, and all of that there, and basically that as well, which is so big, which works really well because it's got a Tate underneath there. Still works really incredibly well as a Tate. It's a 4-channel Tate. That's all that's needed. Doesn't need anything fancy. All of that slimmed down to that, so it's not rocket science. It's quite basic stuff, to be honest with you. Got a bit bored with the over and under sort of the board, so there's just missing one wire bridge. That's about it. Everything else is double-sided, as you can see. Bluetooth decoder, yeah. Depending on which module you use. There's actually pads underneath there, so you can actually add just a standard 4-pin Bluetooth module. And but this is just soldered to the main board just to make it more stable. But this works really well actually. Now that the controller's parked, I can nick its 12 volts. Let's quickly switch that off, which I have done. Let's nick that from there. Also nick the GPS signal there. And a second, I have to put the phone down a second. It's all professional stuff, isn't it, really? Spending half an hour setting this all up. Let's just do it on the fly. It's all nice and honest then. It's all not all superficial. Right, so let's go for that. And power on. He says, well, we get nothing. What have I done wrong? Have I shorted something? Hang on a minute. 1 second, hang on. Seem to have nicked the power, not plugged it in. Where have I gone wrong here? Oh, here we are. Start again. volts, 12 volts, 12 volts. Start again. There we are. So basically, as soon as this thing picks up, this is Bluetooth status. It means it's not connected to a phone at the moment, and this is just this is power. It says this section of the board is working. I decided to sort of break it up into two. I was literally copying the old system. GPS is blinking. It's not picked up a GPS signal. It's still going from cold at the moment. Oh, there we are. And this center transmission. There's no carrier detect at the moment because nothing coming in. There we are. So it's just waiting to lock onto GPS. That light will then be more stabilised and it will reverse the blinking. There we are. So it's basically sending packets but nothing attached to it at the moment, which it's sort of semi-designed to do. But as soon as that locks, then it'll give a packet of precise information. As I say, this light stabilises when you connect something with Bluetooth, and again, this has the ability to transmit, but I didn't really go into that side. So it's just, I could have easily used that section, but I didn't bother with that. The way it was set up in the beginning is the way that it's always worked. So I thought, why not just put everything together on one board and save space? Let's not try to reinvent the wheel. And up to now, it's been working pretty good. Let's just quickly turn the current up. It's nicking a bit too much current. Oh, that'll do. Right, I'm going to give it a few more seconds. I want to sort of like turn this video into a paint drying video. And obviously you've got smart beaconing here and here. Eventually, come on, it will wake up, he says. I might have to move the GPS antenna. It's on a really good ground plane at the moment. I'm surprised I know it's not working. It was working with the right, hang on, that's a bit better. Seems to be picking up a lot more satellites there. Hang on a minute. And obviously, as I say, this is just, oops, I'll tell you what I could do, turn that upside down. Obviously I'm not using this patch antenna. Oops, come on. Let's not get it shorting out on anything. Right, perhaps maybe this is one of those occasions when I should have it's beaconing quite a lot now because I've got the threshold turned down quite low. There we are, it's locked GPS now. So now we've got a really good GPS signal, that's locked. And every packet from now, if the radio was connected to here, it'd be giving position data, APRS, but I need to adjust the beaconing on this and stuff. There's still a work in progress. It's not working brilliantly at the moment, I must admit. Needs a little bit of tweaking. It does work, I've tested it, so it does report position and stuff like that, but I think there's a 100k resistor somewhere here, I can't remember. It needs to be a lot less. It's just way overkill. It's I think somewhere there's a 100k resistor in there somewhere. I think it might be that one. It's overkill. It's strangling too much of the audio. It's reduced it down to nothing. It does work, but it's just there's no adjustability on it. So there we go. Brilliant stuff. Oh, just one other thing here, as I say, if you want to supply external radio power, there's power there for the radio. And you can put diode in here as well. Something I put in as a safeguard. So if you supply 13 volts, if the radio supplies this panel, or whether this panel supplies the radio, there's, you can't obviously cross the two, so you can either put a diode in here and jumper at this. If not, you can just basically, this is now, you can supply this off the radio or vice versa, whatever. The radio has got the ability, as long as you use the tape radio, the radio has got the ability to supply power to the board, which cuts out a lot of the aggravation and vice versa. So by just changing that jumper around, you can either have the board supplying the radio or the radio supplying the board. Obviously it just gets a bit, it just gets a little bit niggly with the current, that's all. And there we are, 73.